Fine. So let us begin now. So this is a course on business analytics. It's a short-term course, and we will have a 1 month assignment also along with it after we are done with this 1 week's training. So this is business analytics course, and we will be doing this with the help of certain tools where we will be utilizing Excel, Tableau, and Python. So these three things we will be taking help of to have the understanding of the business analytics. And now let us begin with this. And we have participants from different backgrounds. So I will try to keep it like as simple as possible so that everybody can understand the whole concept of business analytics. Right, so we can keep it interactive. I have kept the option open that you can always unmute yourself and take part in the discussion. So just to begin with, because I know that here we have participants who already know about it. So I would just like to understand from your side, what is your understanding of business analytics, and then we can carry it forward. So the question is, what is business analytics? And second is, why do you think this particular concept is being practiced a lot in these days? So you are open to unmute yourself and discuss so that it is more interactive.
It is a kind of a data-driven approach towards the business, I think.
Okay, yeah. So data-driven approach, yeah, that's right. Working with data to take some insights for business. Yes.
And do the pure statistical analysis and provide some recommendations to the stakeholders or the
Right.
business.
Correct. Right. Yeah, Sunidhi, you want to say something?
I will answer why is it important nowadays, because it's more of like trading is going globally now, and it's all into how can we put it? It's all into like studies now, because in previous days it was not global, and as we are moving towards the global trading, business analytics is very important, because that way we can study it well, and then we can study like stocks and all. I know the economic background. I'm from economics, so I'm answering like that only.
Yeah.
Yeah. So it's because of that. Because if you have proper data with you, and if you are analyzing it, you can perform better trading into it.
Right. Correct. Yeah. Thanks for your input. Okay. Yeah. So now let's basically start with. So analytics, if you see, this is not a very new term. This has been running for a very long time. And this is all because of data, as you mentioned, which is very right. Okay, so there are very few things which are related to data, and you might have came across these three things that is called as velocity, variety, and volume. Okay, so it was during 1990s, you can say, when basically this analytics was not so generalized, or you can say the way we listen to analytics today. So it was not that kind during 1990s, but as soon as it came to 2000, okay, 1999, 2000, 2001. So that was the time when actually this was being observed, that how the data is explosively getting created. And I'm talking about digital data. So everything was getting digitalized. More of websites, web applications were coming into picture, social media were coming into picture, email services were coming into picture. So the mode of interaction, it all became digital. And before that, it was more of you can say some kind of on paper work was more, but as soon as it came to digital, then these three factors we were able to observe, that is velocity, variety, and volume. Velocity is that speed of digital data which was getting generated was very high. Variety, it was not of a same kind of data, it was having different formats. Today if we see, we have so many formats. Okay, very high level, if we classify, we can have some video kind of data, audio kind of data, images, gifs, textual data, or we can have data from some electronic devices, some sensors. So from there we will get some data again converted into digital data. So different formats of data we face every day. Okay, in fact in our day-to-day lives also we observe different formats of data. Okay, this data can be structured, this data can be completely unstructured, or it can be semi-structured. So different formats of data. And then because this data is growing, the velocity is very high, so that is causing the volume, the amount of data, okay, to be very high. Okay, so because of so much of data getting generated, and understanding that if we try to utilize this data for analysis purpose, then basically we can really have good insights, or good we can say strategy planning for the particular business. Okay, so keeping that in mind, this analytics revolution actually started, and it basically it consumed statistical analysis, as Mahesh, you said. It also encouraged different communities to come up with different softwares, different frameworks, different tools to analyze this data. It came up with a lot of algorithms which can be applied on data. So many things actually happened. So there were existing tools and techniques and algorithms, they were basically again utilized, as well as certain new concepts, certain new frameworks also got evolved. Now, the major types of analytics we will discuss. So these are the four major types of analytics: descriptive, diagnostic, predictive, and prescriptive. So a short, very short description has been given here. Descriptive, it explains what happened. So what happened means it is explaining about the past. Okay, what happened. Diagnostic will help us with analyzing why has it happened. Okay, so whatever has happened, why has it happened, what are the reasons behind it, why has it happened. Next is predictive analytics. So it will tell about the future, what may happen. Okay, so it will be forecasting that what might happen. Then prescriptive analytics, it is recommendation. So it is basically suggestions. Okay, that what should be done. Okay, in order to make some improvements, or what should be done in order to prevent some loss. Okay, so that is something is prescriptive analytics. Now, let us understand them one by one in detail. So, as soon as we move from descriptive to prescriptive, it basically adds to the value of the analysis, as well as it becomes a little bit complex by each step we are going. Okay, so first is descriptive analytics. Here you can see in the diagram, there are one side on the left hand side enablers, on the right hand side we have outcomes. So now enablers, if you see, business reporting or online analytical processing, dashboards, data visualizations. So these are the activities we do for descriptive analytics. Okay, so here it, as we discussed, that it answers the question what has happened. So that is basically is the task of descriptive analytics, what has happened. Okay, so this what has happened, okay, is basically we generate report, so that report will tell what has happened, or we create some dashboards where we will have some charts, okay, some visualizations which will help us to understand what happened. Okay, and data visualization, this part. Okay, so it involves crunching data into understandable chunks. Okay, so data is very huge these days. Okay, and even if we have records of some 10,000 or more, so as a human being we cannot manually basically go and understand that data. We can just understand a few records, like tens or hundreds of records we can understand, okay, as a human being. But if we are dealing with lakhs of records or millions of records, so it is not possible us to manually deal with that. Okay, so in that case we actually require some kind of software which can handle this kind of data. Okay, example, number of likes. Okay, number of likes and number of followers gathered last week. So this is an example of descriptive analytics. So what happened in the past week? Let's say I got 250 likes on a Facebook post. So this is descriptive analytics. I got 5 more followers in the last week. Again, descriptive analytics. Okay, then let's take healthcare example. So how many patients got hospitalized last month? So how many patients, let's say 240 patients got hospitalized. So this is basically again descriptive analytics. It tells about what happened in the past or near past, or maybe a very long time duration can be there, but it is about past, what has happened. Okay, so so this is basically the enabler part where we actually get to know what has happened. Now, what basically is the outcome of this activity? So it summarizes business results. We are able to leverage the data for further insights. Okay, so further analysis we can do, and we can interpret output from predictive analytics. So this is basically very basic and the first step of analytics. Okay, to understand what exactly has happened with with business, with our teams, with whatever domain we are working. Let's say sales. So what has happened in sales? Okay, if there is a HR department, so there also there are so many types of analytics. Let's say employee churn analysis is there, that how many employees are leaving the company. Okay, so that is again descriptive analytics. Today's scenario, if we see, okay, so many people have lost their jobs. Okay, so how many people have lost their jobs? Okay, what is the number in some thousands or in some lakhs? Okay, again the descriptive analytics. Okay, so this is the first kind of analytics, which is called as descriptive analytics. Okay, and what kind of insights we can get out of descriptive analytics? Now if we see that many people are losing out their jobs, so is it right or wrong? It's not good thing. It's a bad thing which we are observing. Okay, so this kind of insight we can get, that what has happened, and whatever has happened, whether it is right or wrong, whether it is good or bad. Okay, this basically we can understand with the help of descriptive analytics. Now moving ahead, second is diagnostic analytics. Okay, so as the word itself tells, that diagnostic is understanding why that particular activity has happened. Okay, so why part. Okay, so the answer, this answers the question why something happened. Okay, for example, now why people are losing jobs. Okay, so the reason would be businesses are not doing good. Okay, why businesses are not doing good? Because of lockdown. Because of lockdown, transport is completely shut down. People are not buying anything other than the very essential items. Okay, so therefore lot of businesses are facing problems, and that is causing the individuals to lose their jobs. Okay, so this diagnostic analytics basically answers the reason why anything is happening. Okay, let's say I have posted two things on Facebook. Okay, so the two posts are, no, yeah, so these two posts are one if you see, so it is about uh, let's say a picture. Okay, so one is a picture. Okay, and another is just text data. Okay, so now you can also understand, if one is a picture and another is a text data. Okay, so what do you think, which one will get more likes and more hits? Will it be a picture getting more likes and more hits, or will it be a text getting more likes and more hits? What do you think?
Obviously, pick.
Yeah, obviously picture. Okay, if I would add a video, then yes, that would cross the picture as well. Okay, so now basically this is descriptive analytics. Okay, that we will get the count, that how many likes picture has got, how many likes text has got. This is descriptive. But why has it happened? Okay, so that basically we will get to know from the fact okay, which is, we can say, a psychological study, that human beings and the human brain better understand, or it is easy for human brain to understand with the help of a picture rather than, okay, going through the text. Second study is that human brain is a bit lazy. It will prefer to go and watch a pic to understand the scenario rather than going for the text and reading the whole lot of that particular piece of text. Okay. Third thing, human beings are too busy doing a lot of stuff. They don't have time to read all those texts. Rather, they can just have a look at the pic and understand. So these are the reasons why basically pic is getting more hits, more likes. Okay. So the reasons, finding out the reasons, is basically diagnostic analytics. One of the example given here is retailer example. A retailer can drill the sales and gross profit down to categories to find out why they missed their net profit target. Okay. So the what is descriptive analytics? They did not meet their net profit target. This is the descriptive analytics. Okay, so the expected profits were not met. Now why they were not met? So they can do drill down to the sales and gross profit. Okay, so here basically they will dig it down, that how many sales were there, okay, which items were sold, which items were having how much profit margin. Okay, from there they will get to know that why they did not meet up the target. Okay, so this is diagnostic. Now moving ahead to the next one, which is called as predictive analytics. Okay, so prediction means telling something about future. Okay, so here are a lot of things. Okay, so forecasting can be there. Okay, so as you can see, weather forecasting can be one of the examples. Then regression. So regression is basically relationship. Okay, you have something, some data, you can name it as x, and you have some data, you can name it as y. Okay, so regression is basically telling that if x is increasing, then is y also increasing? So if y is also increasing, that means x and y are related, or we can say they are correlated. Okay. If x is increasing and accordingly y is decreasing, so then also they are related, but they are not, they are inversely proportion to each other. Okay. So they are inversely related to each other, but they are related. So that is the concept of regression. Okay. So, and next use case is text analysis. Okay, so textual data. So, a lot of textual data we receive, like social media, a lot of text we receive. Then blogging sites, lot of text we receive. Twitter, lot of text we receive. Okay, then for research, lot of documents are there. Again, text analysis is required. Okay, so text analysis is another important use case in predictive analytics. Then this all basically is done. Okay, the whole analysis is done with the help of a concept called as machine learning, that basically does all of this part. Okay, then classification is also there, so which is also a sub part of under machine learning only. So classifying, for example, again taking the example of this COVID-19. So if you see, like COVID-19 or swine flu came. Okay, so when the first patient must have approached the doctor, so that time the doctors must be diagnosing that particular patient based upon their past experience and based upon the whatever symptoms they were able to identify in the patient. Okay, they were actually comparing it with whatever they did with existing diseases and existing patients who met with those diseases. Okay, but when they found that even after giving them medication, the patient is not getting well, or he or she is not getting treated well, then and the result was death. The result was death during this corona. Even during that swine flu, the same thing happened. Okay, so they started thinking that we are diagnosing uh, with the parameters we are able to see in that particular patient, but he's not getting cured. So therefore this is not basically a disease out of the existing known diseases. This must be something else. Okay, there are two possibilities: whether that particular patient has got some immunity issues, or this is some new disease. Okay, and the symptoms are similar to a lot of other diseases. Okay, so then basically they must have started analyzing all the parameters of that particular patient and trying to understand what is differentiating, like which symptoms are differentiating this particular disease from other symptoms. Okay, so again that is an example of, we can say, classification and a mixture of clustering. Okay, where we group the particular items based upon their properties. So here in this example we are making like different categories of diseases. Okay, so cough and cold is a common thing which may happen in lot of diseases. Okay, but along with cough and cold there will be certain more parameters which doctors test, which will identify whether this is a normal cough and cold, whether it is a viral, whether it is something else. Okay, so that is classification. So in predictive analytics, these all things will tell something about future. Okay, what might happen in the future. Okay, so the question which is being answered by predictive analytics is what is likely to happen. Okay, what is likely to happen in future. Okay, so it uses the findings of descriptive and diagnostic. Okay, so as I said, descriptive is the very basic and foundational analytics. Okay, so that is more of a, you can say, exploratory data analysis. We are exploring the data and we are trying to understand the data. So that is more of a that kind of thing, descriptive. And diagnostic, just now we discussed what exactly is diagnostic analysis. Okay, so here one example is given. A telecom company can identify subscribers who are most likely to reduce their spend and trigger targeted marketing activities to remediate. Okay, so yeah, now basically uh, this can happen. Let's say some network issues people are facing, like in between. Yes, Mahesh, you want to say something?
Kushal, there is some kind of background noise is there. Some kind of, I think, news channel is going on. Some people are talking about something and all. So, if possible, can you please ask to all the participants to check what is happening with them?
Yes, yes, just a second. Yeah, I'll request all the participant to mute meanwhile. Okay, whenever you want to discuss, you can raise hand, we can discuss. I think now everybody has muted. And is there any noise now? Yeah, I can see there is no noise now.
Yeah, there is no
Yeah,
noise
yeah,
now.
yeah. Okay, thank you. Thanks. Right. So we were discussing about this predictive analytics. The use case is telecom company. Okay, so if you are facing problem, let's just take for example, if we are facing network problems with idea. Okay, so if this problem continues for longer time, okay, then we would try to switch to another operator. Okay, if we face any kind of problems. Second could be, okay, one can be network issues. Okay, second could be their price. Okay, whatever plans they are offering, okay, if the price is also getting higher, then also we would try to switch to some other network. Okay, some other operator. So certain parameters will define that where do we want to, or we live in a particular locality. Okay, so in a particular area we live, where basically idea networks are not good. Again, we would like to switch to some other operator. Okay, but what this company can do is they can basically do one thing, that they can do some marketing campaigns. Okay, with some better pricing. Okay, so they can offer some better pricing, and those better pricing can attract customers. Okay, second, they can work upon improving those particular areas where the network is not so good. Okay, they can go and make some improvements. Okay, in the network availability in those areas, so that their customers don't reduce their spend or don't move out and choose some other operator. Okay, so this basically helps in this predictive analytics helps that whether the people will reduce their spend, whether people are moving out of their services. Okay, so what will be the likelihood, or what will be the tentative number of customers who will be doing this activity, reducing their spend or moving out. Okay, so that basically we can get from the predictive analytics. During the current situation also, lot of analysis is being done, lot of studies are being done by different research centers, and everybody is coming out with their own research about the predictions on corona. Okay, and also they are suggesting that will this go on further, will this end. Okay, so a lot of formulas are being created. Okay, so that is even happening with current situation also, right? Next part is prescriptive analytics. So prescriptions, we normally listen to this particular term in the hospitals with the doctor itself. Okay, so they prescribe some medicines. Okay, there it is very much popular. Okay, so prescription is something which is, you can say, it's a recommendation, it is a suggestion, it is a kind of a strategy you need to follow. Okay, so that is a prescription. Okay, and why is it given? If you go to a doctor and if he writes a prescription that you have to eat such kind of food, you have to follow this kind of timetable, you have to take these medicines. Okay, so why the doctor is giving this prescription? For the betterment of that individual's health. Okay, so the objective is, if you see here, optimization, that is betterment, simulation, actionable information for decision making. So the objective is that something good or better should happen. Okay, that is the objective. Okay, but when? In the future. Okay, something better should happen in the upcoming future. Okay, so deliverables, reports, algorithms, models and codes, recommended actions. Okay, so these, or in simple terms, strategies, some action plans. Okay, so those will be basically the output of prescriptive analytics. Okay, yes, and streamlining, simulation, game theory, decision analysis, these are the techniques used for prescriptive analytics. Okay, so now if we see, uh, dealing with the past data is the activity of descriptive analytics. Okay, again, if I say what descriptive analytics output is, it is just telling what has happened in the past. Then next one, diagnostic. It is also completely dealing with the past data, and it is telling why has it happened, but it is not telling anything about future. Okay, so it is limited to past data itself. Then once we start moving towards predictive and prescriptive analytics, so 100% without any doubt, they actually need complete help of past data, but based upon the past data, they start making some analysis for the future. Okay, so predictive analytics, it makes the it makes the analysis for the future, like what may happen, and prescriptive analytics basically gives a report or some action plan that what could be done, what should be done in order to basically uh, you can say to achieve some objectives for the future. Okay, so here if you see it, its purpose is what action to take to eliminate the future problem. Okay, this is first part. Or to take full advantage of current trend. Okay, so there are two things: what action to take to eliminate the future problem. Okay, so if there is some kind of problem, issues, or expected losses, so what actions to take to eliminate them? Because if you prevent a loss, that's a profit. And if your business is doing well, then how you can take the full advantage, complete advantage of current trends. Okay, so prescriptive analytics is based on optimization that helps achieve best outcomes, and stochastic optimization that helps to understand how to achieve the best outcome, to identify the data uncertainties, to make better decisions. Okay, so the primary purpose is to basically achieve some better outcomes, and to achieve some better outcomes we need to have some kind of strategies planned. Okay, so this is basically prescriptive analytics. Now moving further, okay, moving further, there are two more analytics. One is called as inferential, and another is called as cognitive analytics. Okay, so those were the four standard analytics. Now let us discuss these two as well, inferential as well as cognitive analytics. So inferential analytics, as you can see in the this flow diagram or a chart, that inferential analytics, it used to go beyond sample taken from the population. Inferential analytics, it used to draw calculation about conclusion about population. It used to interpret data, as well as the most important task it does is statistical significance. It determines the statistical significance based on low probability of observed results due to a chance. So I'll explain what exactly inferential analytics does. So let's take one example. Let's say you are walking a distance of 100 meters. Okay, so 100 meters distance you are covering. Okay, you are having a regular speed. Okay, the way you always walk, and this regular speed basically makes you to cover that particular distance in 1 minute. Let's assume that. Okay, now you increase your speed. Okay, so once you increase your speed, okay, so the speed is now fast. So if the speed is fast, then you were able to cover the same distance in just 0.5 minutes. Okay, or basically 30 seconds. Okay, so okay, just assume it as 30 seconds. And then if you slow down your speed, in that case you will take, let's say, around 2 minutes. Okay, so what is happening here? One is regular speed, second is fast, and third is slow. So if it is regular, the time is getting 1. If it is fast, time is 30 seconds. If it is slow, time is 2 minutes. So that means the speed at which you are walking is the input, and that is actually affecting the output. That is actually affecting the output. Okay, let's take one more parameter. Let's say you do this activity, like you do walking every day. Okay, so if you do walking every day, in that case, let's assume that someday your mood is wonderful, you have a wonderful mood, and someday like uh, you are upset. Okay, so let's say one day you are basically very happy. So for happy I'll write H. Okay, so you're very happy. Another day you are sad, and one more day, let's say you are angry. Okay, now tell me, if you are happy, how does it affect in time? Okay, the time taken to cover that particular distance. If you are sad, then again, does it affect the time of completing that particular area? And if you are angry, will it basically affect the the time taken to complete that particular distance? Okay, what do you think? Your mood, will it affect the time taken to complete that particular distance?
No.
Yes, obviously no. Okay. So time is not the parameter which will basically affect the output. Okay. So this inferential analytics is working here to help us out to identify the relationship between the input and output. Okay. So the first question it answers is whether the input is related to output. And secondly, if they are related, then what is the strength of that relationship? Okay, so this is very important in a lot of areas, that because if you have, let's say if you have 100 parameters, okay, and 100 parameters you want to analyze, okay, and that 100 parameters gives one output, and let's say that output is y, okay, 100 parameters. So if you are able to understand out of these 100, only 20 parameters actually affect the output y, rest of the parameters, they don't affect y, or whatever the effect is, that is negligible, then will you go for 100 parameters for the analysis, or will you go for only 20 parameters? Obviously 20 parameters, right? So only 20 parameters we will go for doing the analysis. Okay, so now how did we basically get to know? With the help of inferential analytics, we get to know that these 20 parameters are actually important, and they are affecting the y, they are affecting the output. Let's say there were 10 more parameters which were affecting y, okay, which were also affecting y, but the strength of the relationship was very weak, it was very poor. So if the strength was very poor, we can ignore those 10 parameters. We are not considering those parameters in the 20. Okay. So again, yes, Mahesh, you have raised the hand. Do you want to say something?
No, I think it was from the last time only.
Okay, okay, fine, fine. Yes. So inferential analytics uses statistical tests to see whether a pattern we observe is a chance, due to a chance, or due to the program or intervention effects. Okay, so sometimes it happens, okay, sometimes it happens that uh, we see something, let's say normally in Indian culture, if you go out, okay, so we used to take curd, okay, with the sugar, okay, but that curd with sugar, okay, let's say if I want to analyze that, taking curd will with sugar, and one parameter is, okay, one parameter is, let's say, rash driving. So out of these two parameters, okay, which one is very strongly related to chances of accidents to occur? Rash driving or taking curd with sugar?
Rash driving.
Yeah, so rash driving is strongly related to the probability that accident will happen, because people, they might have some food, they might not have some food, okay, but if they will drive safely, properly, then the likelihood or the chances of meeting an accident are very low. But if somebody is driving uh, not properly, then the chances of getting accident is more. Okay, so there are two things. One is basically, are they related? Okay, here we can see that uh, yeah, if there is a relationship, okay. Second, what is the strength of that relationship? Okay, so one is to understand, is there a relationship, and second is, what is the strength of that relationship? This is the the objective of inferential analytics. All right, now moving towards the next part, okay, that is called as cognitive analytics. Cognitive analytics, okay. Now this cognitive analytics is, you can see so many terms are written here, okay. So here, your RDBMS, your databases, your information integration, ECM, big data platform, standard reports. Okay, so if you go from down to up, then basically it goes from your descriptive, your diagnostic. Okay, so it goes from there and it reaches basically here till cognitive analytics. Okay, so cognitive analytics, you can say it is the most advanced part of business analytics. It actually deals with the way our human brain works to understand things, to interpret things, to basically take out some decisions. Okay, so that kind of approach basically cognitive analytics has. Okay, so here you can see it basically includes natural languages, learning and reasoning. So all this part is basically a part of your artificial intelligence. It is a part of your machine learning. Okay, so cognitive analytics is, you can say, a bridge which actually is joining your business analytics and your data science. Okay, where your artificial intelligence, machine learning and deep learning, all these concepts come into picture. So it is basically that particular point where these things meet. Okay, so that overlapping part is cognitive analytics. Okay, now cognitive analytics combine artificial intelligence and machine learning algorithms with intention to produce behavior of human brain. Okay, so the way humans actually deal with the worldly situations. Okay, so that kind of approach is the objective of cognitive analytics. Okay, it is yet another analytics level sitting on top of existing ones, as shown in the figure we just observed. Okay, so this is the sixth type of analytics. Okay, so we will be putting more focus on, as I said, the four types of analytics. Okay, descriptive, diagnostic, predictive, and prescriptive. We may touch upon the other two as well while doing the analysis. Okay, so this is the primary conceptual presentation I just covered. Now we can have a few questions raised out of the discussion we just did. Okay.